Hello, let me introduce myself. My name is Gideon Najoan with student ID 2411011060016, so I'm here to do an assignment from Prof.Benny Pinontoan about using the Blender application for 3D animation. So the first thing is to create a computer and enter the computer. Second, encounter the transistor.
A transistor is a semiconductor device used to control the flow of electrical current in a circuit. It is primarily used for amplification and switching. The transistor consists of 3 layers of semiconductor material, forming 3 terminals: the base, the emitter, and the collector. In a bipolar junction transistor, a small current flowing into the base terminal controls a much larger current flowing between the collector and emitter. For example, in an NPN transistor, a small current applied to the base allows a larger current to flow from the collector to the emitter. In a PNP transistor, the current flow is reversed, with the emitter supplying current to the collector through the base. In field effect transistors, the flow of current between the source and drain terminals is controlled by the voltage applied to the gate terminal. This voltage modulates the conductivity of the semiconductor material, regulating the current flow. Transistors are widely used in electronic circuits because they can amplify weak signals and act as switches to control high-power devices. Their ability to precisely regulate current or voltage makes them foundational components in modern electronics.
What is a logic gate? A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Most electronic devices we use today will have some form of logic gates in them. For example, logic gates can be used in digital electronics such as smartphones and tablets or in memory devices. In a circuit, logic gates work based on a combination of digital signals coming from its inputs. Most logic gates have 2 inputs and 1 output, and they are based on Boolean algebra. At any given moment, every terminal is in one of the 2 binary conditions, true or false. False represents 0 and true represents 1. The NOT gate is the simplest of all logic gates. It performs the logical negation operation. This means it inverts the input signal. If the input is 1, true, the output becomes 0, false, and vice versa. Symbol, a triangle with a small circle, called an inversion bubble, at its output. The NOT gate has only 1 input and 1 output. Its job is to flip the value of the input. For example, in a circuit, if a sensor sends a signal that something is off, represented by 0, the NOT gate can change that signal to on, represented by 1. This is useful for toggling or reversing binary conditions in digital systems. The AND gate is like a strict condition checker. For example, in an automated security system, if 2 sensors must detect movement simultaneously to trigger an alarm, an AND gate can handle this logic. Only when both conditions are satisfied will the output activate. The AND gate performs the logical AND operation. It outputs 1, true, only if all of its inputs are 1. If any input is 0, the output is 0. Symbol, a D-shaped curve leading to a single output line. The OR gate performs the logical OR operation. It outputs 1, true, if at least one of its inputs is 1. The output is 0 only when all inputs are 0. Symbol, a curved shape similar to the AND gate but more pointed at the input side. The OR gate is like a permissive condition checker. For example, in a home lighting system, if a switch in the living room or a switch in the bedroom is turned on, the OR gate can ensure that the light will turn on. This gate is useful when any condition being true should trigger an event.